Hello class, how are you? I hope you all are good. Today we'll start with a new chapter, computational thinking. So, what is all about? So in certain situation when we think if suppose it is raining outside whether I have to take umbrella or not. So this way we analyze the problem and for that problem we take out certain solution. So this problem solving approach is actually computational thinking and there are various components which we'll study in the chapter. So let's plug in the chapter. Computational thinking, components of computational thinking, algorithm and sequence, branching if then statement, abstraction, debugging. Let's just start the chapter.
Computational thinking. Computational thinking is an approach that enables us to solve any problem through an analytical approach. It is a problem-solving process that focuses on logical and critical thinking. However, this approach can be applied for problem solving in everyday life. We need this approach when we need to break down a complex problem into parts. It develops possible solutions for it. This approach proves useful in handling simple tasks to difficult ones. Features of computational thinking. Look at the following features of computational thinking approach. It is a problem-solving process. It helps in breaking a problem into parts and finding a pattern. It helps in designing efficient software systems. Components of computational thinking. Look at the various components of computational thinking. Decomposition. Decomposition involves breaking down a problem into a series of small problems. This makes complex problems easier to solve. Pattern recognition. Pattern recognition involves finding similarities by observing patterns or trends. It is a way to solve a new problem based on our past experiences. Abstraction. Abstraction is the process of filtering out the data which is needed from the whole. It focuses on important information and ignore the rest, i.e., the characteristics or patterns that we don't need in order to concentrate on the required data. Algorithms. Algorithms involve developing a list of steps that can be followed to complete a task. Designing an algorithm is an important component of computational thinking. We have already learnt about decomposition and patterns in our previous class. Now, we are going to learn about other components in detail. Algorithm and sequence. The step-by-step instructions to solve a problem is called an algorithm. Let us understand it with the help of an example. What steps would you follow to buy a chocolate? The possible steps are as follows. Step 1. Take money and go to the nearby shop. Step 2. Choose the chocolate of your choice. Step 3. Pay money to the shopkeeper. Step 4. Take the balance amount if any. Finally, you get the desired result, i.e., a chocolate. Here, we have created an algorithm that consists of these steps. Each step is an instruction to be performed. When we cannot change the order of the steps, it is called a sequence. Sequencing is the particular order in which instructions are performed in an algorithm. Branching if-then statement. This must be heard by us from our parents or elders. If we get good marks in exams, then we will get a PlayStation action. If the condition is met, we get the promised thing. Similarly, some algorithms also contain these condition action-based instructions. The if-then is a branching conditional statement. It is used to decide the execution of statements on some conditions. First, the condition is checked, and if it is true, only then a certain course of action takes place. Let us understand this with the help of an algorithm. Step 1. Go to a restaurant. Step 2. Order biryani and noodles. Step 3. If biryani arrives first, condition. Step 4. Then pick a spoon action. Step 5. If noodles arrives first, condition. Step 6. Then pick a fork. Action. Here, we are instructed to pick a spoon if biryani arrives before the noodles, and if noodles arrives first, then pick a fork. Abstraction. Let us understand it better with the help of an example. We come across various shapes in everyday objects. We all are fond of pizza. If we notice the different shapes across various stages, we observe that the pizza box is square, pizza is circular round, and pizza slice is triangular. Debugging. While writing an algorithm, we sometimes make mistakes, due to which it does not work correctly. These mistakes are called bugs. Debugging is a process of detecting and removing the bug's errors. When these bugs are removed, algorithms work correctly. Learn to debug the program using the real-world examples of algorithms. Have a look at the following algorithm of making a strawberry shake. Step 1. Cut strawberries into pieces. Step 2. Transfer them into blender. Step 3. Pour it into the glass. Step 4. Blend until the mixture turns smooth. Step 5. Add milk, sugar and ice cubes. Step 6. Serve it cold. The algorithm defines 6 steps that are required to be run in order to complete the task of making a strawberry shake. However, if we read through the steps one at a time, we will observe that they are in the wrong order. This is an error bug in our algorithm and will stop us from successfully completing the task. Step 3 should replace Step 5. So, we need to debug this algorithm and rewrite the steps correctly. After debugging, the algorithm works correctly. Throwback. Computational thinking approach is needed to break down a complex problem into parts and develop possible solutions for it. There are 4 components of computational thinking. Sequencing is the particular order in which instructions are performed in an algorithm. The if-then statement is used to decide the execution of statements on some conditions. Abstraction is the process of filtering out the data which is needed from the whole. Debugging is the process of detecting and removing the bug's errors. After debugging, the algorithm works correctly.